All right, let's go ahead and answer D through, I believe, F on this slide. So we're just going to put our our sequence into table format. So we talk about our sequence having a term 1, a term 2, a term 3, 4, and 5. We already have term 3 filled in, but term 1 would be -9. Term 2 is -5. Term 3 is -1. Term 4 is 3. And term 5 is 7. So what is T of n when n equals 0? In other words, what is term 0? So if we're looking at our table, we have to go backward 1 to get to term 0. So normally we would add 4 to get from one term to the other if we're moving forward, but to move backwards, we're going to have to subtract 4. So now we'll get -13. So -13 would be T of 0. And then we're just going to go ahead and plot those points. So we have the point -1, the point 0, -13. So I'll have to move my graph down a little bit here. 0, -13. And then we have the point 1, 9. And then we have the point 2, -5. And then 3, -1. And then 4, 3. And 5, 7. And this looks like it's a linear pattern, right? I mean, that's something we should recognize here. Now, it asks, should the graph be continuous, where we connect the dots, or discrete, where the dots are not connected, and why? So this really comes down to deciding whether or not the numbers in between 0 and 1 will be used for our inputs. And because we're talking about a sequence, we can only talk about term 1, term 2, term 3. We can only talk about terms that are whole numbers. So in that case, you know, if we did put, if we did connect this, what we're saying is that this point is part of our domain in our range. And that point is the point 1/2 -11. So that would be saying that there's a term 1/2. And that doesn't make any sense. So because we can't have these fractional terms, we don't actually connect our graph. So it's just discrete points. So the answer to this would be discrete. And again, you can go ahead and type your answer in as to why in the box below.